Hi, my name is Shehroz Ahmed, and in this video I'm gonna cover a topic of GCSE chemistry, and that is quantitative chemistry. So in the quantitative chemistry, the first thing that we have to cover, we have to discuss, is the concept of mole. So what basically the mole is. So let me just write down the definition, then I can explain you the mole. Mole is basically, it is the unit to represent the amount of substance. Okay, so it is used to represent the amount of substance, and basically it is used to represent the amount of atoms, or the amount of particles, amount of molecules, amount of ions, and some particular amount of mass. So the formal definition for the mole is the amount of substance will be 1 mole when the particles becomes equal to 6.02 times 10 to the power of 23. So anything that has particles equals to 6.02 times 10 to the power of 23 will be equal to the 1 mole. So let's suppose if we have let's suppose pen, if we have 6.02 times 10 to the power of 23 pens, then that amount of substance will be equal to 1 mole of pen. But because it will be way too much, it's like that amount will be so large, so that's why we cannot use the amount, the unit of mole in for the ordinary substances in our daily life. So we use this unit in order to represent the amount of atoms in a substance. Let's suppose we have 12 gram of carbon. So in the 12 gram of carbon, there are 6.02 times 10 to the power of 23 atoms of carbon. Similarly, if you have 18 gram of water, it means it has 6.02 times 10 to the power of 23 molecules of water in 18 gram of water. So we use this unit of amount of substance to represent the smaller object at the atomic level, basically. Alright, so in this chapter we have to basically cover the concepts of calculating the masses from balanced equation, because it's a topic of quantitative chemistry. So we will see how the mole plays an important part in finding out the unknown masses from a balanced chemical equations. But let me just tell you the formula first of all. So the formula for the mole is equal to the mass given of any substance divided by its molar mass. For example, the molar mass of carbon is 12 gram. So if we have 20 gram of carbon and we want to find out the number of moles, so that will be equal to 20 over 12. So we'll get the number of moles. Okay, so now let's discuss the calculation of masses from a balanced equation. So for that purpose, we will discuss an example, and we will see how we can calculate the masses, the unknown mass, from a balanced chemical equation. Alright, so calculating masses from a balanced equation. So we have been given a balanced equation. So the example, in the example it says that we have 6 gram of magnesium, 6 gram of magnesium that has been burnt to produce magnesium oxide. So now we have to find out the amount of magnesium oxide, like how much magnesium oxide has been produced by burning 6 gram of magnesium. So as you can see over here, so for this purpose, first of all we have to work out the number of moles of magnesium that has been burned. So because it's 6 gram of magnesium that has been burned, so in order to find out the number of moles, we will find that the moles of magnesium will be equal to 6 gram over 40 gram, because 40 gram is the molar mass of magnesium. I'll write it here. So the molar mass of magnesium is 40, the molar mass of oxygen is 16. So from here I'll just do the calculation and we'll get the number of mole. So the number of moles that I got are 0.15 mole. Now 0.15 mole of magnesium will burn and it will produce the magnesium oxide. Now over here you can see this two and this two. These are the number of moles of magnesium and magnesium oxide if the mass of magnesium is equal to 1 mole. Okay, so we can say I'll write magnesium over here, magnesium oxide over here. So from the balanced chemical equation, 2 moles of magnesium produces 2 mole of magnesium oxide, so that 0.15 mole of magnesium should produce x mole of magnesium oxide. So I'll just cross multiply them. It'll become 2 times 0.15 equals to 2x. So this 2 will get cancelled and I'll get x equals to 0.15 mole. So 0.15 mole of magnesium oxide will produce. Now in order to find out the mass of magnesium oxide, I will again use this formula that mole is equal to mass over molar mass. So the mass of magnesium oxide will become equal to number of moles multiplied by the molar mass of magnesium oxide. So as we have seen that the molar mass of magnesium is 40, the molar mass of oxygen is 16. So the molar mass of magnesium oxide will be equal to 56. So the mass of magnesium oxide that will be produced equal to 0.15 times 56. So from here I'll get the mass of magnesium oxide that will be produced. So 0.15 times 56 will give me 8.4. So by burning 6 gram of magnesium, we can get 8.4 gram of magnesium oxide. So this is how we can find out the mass from a balanced chemical equation. We have to work out the number of moles first, and we have to see the molar ratio. We have to compare them and work out the unknown moles, and from those moles we can get the mass. So this is it. Now let's discuss the second example. Okay, so now we have to see this topic. It says balancing equations by using the reacting masses. Okay, so over here we have been given an equation. In this equation, carbon is being reacted with the zinc oxide and producing carbon dioxide gas and zinc metal. Now in the question we have been given that the mass of carbon is 1.2 gram, that is being reacted with zinc oxide, and the mass of zinc oxide is 16.2 gram. The produced carbon dioxide has a mass of 4.4 gram, and the mass of zinc that has been produced is 13 gram. So now we have been given these masses. So by the information of these masses, we have to balance our chemical equation. So for that purpose, first of all, what we have to do is we have to work out the number of moles for each reactant and product. So let me just write down the molar masses. So the molar mass of carbon is 12, molar mass of zinc is 56, molar mass of oxygen is 16. Okay, so let's find out the number of moles for all the reactants and the products, and from the information of the number of moles we will be able to work out we'll be able to work to balance the equation basically. So the moles of carbon will be equal to 1.2 divided by the molar mass, because the mass of carbon that is given over here is 1.2 gram and the molar mass is 12 gram, so it will be equal to 0.1 mole. Now the moles of zinc oxide, that will be equal to 16.2 divided by the molar mass of zinc, that will be 56 plus 16, so that will be equal to, I'll just do it quickly, so it will be equal to 0.225. These are the number of moles of zinc oxide. Now the number of moles of carbon dioxide, so I'll write it here, moles of carbon dioxide, that will be equal to 4.4 divided by the molar mass of carbon dioxide, that will be 12 plus 16 times 2, so it will become equal to 0.1. Now the moles of zinc, so the moles of zinc will be equal to 13 divided by 56, so that will be equal to 13 divided by 56, 0.1 0.23. Alright, so now we have found the number of moles of carbon, zinc oxide, carbon dioxide, and zinc. Now we have to see what is the smallest number of moles that we got. So the smallest number of moles that we got are 0.1. So we'll divide all the moles by 0.1. So dividing all by 0.1, 0.1, 0.1, 0.1, we will get the number of moles that we'll write in our balanced chemical equation. So for this one, 0.1 over 0.1 is equal to 1. 0.2 over, like, it's approximately equal to 0.2, so 0.2 over 0.1, it will be equal to 2. 0.1 over 0.1, it's 1, and 0.2 over 0.1, it's also equal to 2. So with carbon we will write 1, so it's 1 over here. With zinc oxide we have to write 2. With carbon dioxide we will write 1 over here, and with zinc we'll write 2. Since there is no need to write 1 with the in a balanced chemical equation, so I'm just going to remove 1. So this will be my final balanced chemical equation. Carbon plus 2 zinc oxide will form carbon dioxide and 2 atoms of zinc. So this is how, by the information of the masses, you can balance out your chemical equation. Now the next thing that we have to discuss is the concept of the limiting reactant in a chemical reaction. So let me just erase it and then we'll move on to that. Alright, so limiting reactant. Limiting reactant is basically, it is the reagent that used up earlier in a chemical reaction. So such a reagent is called the limiting reactant. Alright, so this is the formal definition of the limiting reactant. In order to understand it, let's go over an example. Alright, so here we have a chemical reaction. In this reaction, 9.2 gram of sodium is reacting with 8 gram of sulfur to produce sodium sulfide, and we have to judge which one is the limiting reactant, either the sodium or the sulfur. So first of all, I have to balance this chemical equation. It's Na2S, it's not NaS, it's Na2S over here. So we have 2 atoms of sodium on the right side, but we have 1 atom of sodium on the left side. So what I do is I'll just balance it out. So I'll write 2 over here. So 2 atoms, 2 moles of sodium on the left side, and 2 moles of sodium on the right side. So it's a balanced chemical equation. Okay, now after balancing out this chemical equation, we have to find out the number of moles of sodium, and we have to work out the number of moles of sulfur, and then we will see how we can work out the limiting reactant. So the moles of sodium will be equal to 9.2 divided by 23. So 23 is the molar mass of sodium, and 9.2 is the mass that has been given for the sodium, so it will be 0.4 moles. So we have 0.4 moles of sodium. Now work out the moles of sulfur. So that would be 8 over 32. 32 is the molar mass and 8 is the mass of sulfur. So that will also be equal to 0.4. 8 divided by 32. No, it's 0.25. So we have 0.25 moles of sulfur and 0.4 moles of sodium. So in order to produce sodium sulfide, let's find out the let's see the molar ratio. So we need 2 moles of sodium to produce 1 mole of sodium sulfide. So that I'll write it over here. This is sodium, this is sodium sulfide. I'll do the comparison of sodium with sodium sulfide over here, and on this side I'll do the comparison of sulfur and sodium sulfide. Alright, so from the equation it says that 2 moles of sodium produce 1 mole of sodium sulfide. So I'll write 1 over here, and from the mass given we have got 0.4 moles. So 0.4 moles of sodium will produce x moles of sodium sulfide. So from here I'll get the value of x, that will be equal to 2x is equal to 0.4. So x will become equal to 0.2. So 0.4 moles of sodium produce 0.2 moles of sodium sulfide. Now similarly I'll find out the moles for the sulfur. So from the equation we have 1 mole of sulfur produces 1 mole of sodium sulfide. Similarly 0.25 moles of sulfur will produce x moles of sodium sulfide. I'll cross multiply them, and from here I'll get the value of x equals to 0.25. So as you can see from here that the sulfur is producing more moles of sodium sulfide and sodium is producing less moles of sodium sulfide. So the reagent that is producing less moles of sodium sulfide is our limiting reactant. So in this case the sodium will be our limiting reactant and the sulfur will be in excess. So this is how you can do the calculation and work out for your limiting reactant. So in this reaction sodium will used up earlier and sulfur will remain in the reaction. Alright, so this is it for the concept of limiting reactant. Now there's another one last concept that we have to discuss for this lecture, and that is about the concentration. Alright, so for this concept of concentration of solution, we have to first understand the solute and the solvent. So for example, we have a beaker. In this beaker there is water, and in this water we have put some sodium chloride salt in solid form. So this sodium chloride is basically, it is called the solute, and this water is called the solvent. And once it is mixed in this water, it will become a solution. So the concentration of solution is basically, it is the amount of solute that is dissolved in the given amount of a solvent. So in simple words we can write it as the amount of solute in a solvent is called the concentration of the solution, is called the concentration of the solution. If you have more solute in a given quantity of solvent, then the concentration of the solution is higher. If you have less solute in a given quantity of solvent, then the concentration will be lesser. So the formula for the concentration is C is equal to N over V, where N are the number of moles of the solute that will be dissolved in the solvent. So number of moles of solute, V is basically the volume of the solution, like the complete solution, and C is the concentration. So this is the formula to find out the concentration of a solvent in a solution. Now the number of moles will be just represented by mole, mol, and the volume is represented in dm cube, decimeter cube. So dm cube are also equal to 1 liter, and also dm cube is equal to like 1000 centimeter cube are equal to 1 dm cube, and the unit of the concentration will be equal to the mole per dm cube. So this is the formula that you have to remember in order to work out the concentration of solution. Alright, so now we will do some exam related questions in order to get a firm grip on the concept of quantitative chemistry. So over here we have a question. It says calcium sulfate is used as a coagulant in the product of tofu and to make plaster of Paris. The molecular formula of calcium sulfate is here, CaSO4. Calculate the relative formula mass of CaSO4. So relative formula mass means we have to find out the mass of this whole thing, CaSO4. So the mass of calcium is 40, the mass of sulfur is 32, and the mass of oxygen is 16. So it has 1 calcium, 1 sulfur, and 4 oxygen. So what we do is we'll just add the mass of all of them and we'll get the relative formula mass. So it will be like 40, that's the mass of calcium, plus 32, that's the mass of sulfur, plus, because it has like 4 oxygens, so it will be like 4 times 16. So now I'll just solve them and add them up, and we'll get the total formula mass. So 40 plus 32 plus 4 times 16, so that would be equal to 64. So the formula mass is 136. So this is it. Now it says what is the mass of 1 mole of calcium sulfate. So 1 mole of something is equal to its relative formula mass. So 1 mole of calcium sulfate will be equal to 136 grams, because this is the relative formula mass. It's just like 1 mole of carbon is 12 gram, because the molar mass of carbon is 12, and the molar mass of nitrogen is 14. So the molar mass of the mass of 1 mole of nitrogen will also be equal to 14. So same goes for this one. The mass of 1 mole of calcium sulfate will be equal to its relative formula mass, that will be equal to 136 grams. Now let's move on to part C. Alright, so in this one it says what mass of calcium sulfate would be needed to produce 18 gram of calcium. Okay, so for to do this one, I'll write calcium over here and calcium sulfate over here. Now 40 gram of calcium produces 136 gram of calcium sulfate, as we have just seen. And if we have 18 gram of calcium, x gram of calcium sulfate will be produced. So I'll just cross multiply them. It will become 40x equals to 18 times 136. So x will become equal to 18 times 136 divided by 40. So I will get the mass of calcium sulfate. So the mass I got is 27.2 grams. So if we have 18 gram of calcium, it will produce 27.2 gram of calcium sulfate, because in this calcium sulfate you can see there is only one atom of calcium, and the mass of one atom of calcium is 40. Now let's move on to part D. In part D it says calculate the number of moles in 320 gram of iron oxide. So first of all we have to find out the molar mass of iron oxide. Then we'll use the formula of mole equals to mass over molar mass, and we'll get the number of moles. So the molar mass of, like, the formula mass for iron oxide will be equal to so before doing that, there's some calculation error over here. So when we'll solve it, it will become 61.2 grams. So this is not 27 point something, it's 61.2 gram. Now let's come back onto this one. So the molar mass of iron, the formula mass of iron oxide will be equal to 2 times 56, because the molar mass of iron is 56, plus 3 times 16. So once I'll add it, it will become equal to 160 gram. So the formula mass of iron oxide is 160 grams. So now the number of moles will be equal to the mass given, that is 320 gram, divided by the formula mass, that is 160 grams. So the answer is equal to 2 mole. Okay, now for the next one it says calculate the number of moles of 14 gram of C2H4. It's basically ethene. Yeah, so I'll do the same working. So first of all I have to work out the formula mass of C2H4. So that would be equal to 2 times 12 plus 4 times 1. So it will be like 24 plus 4 equals to 28. So the number of moles will be equal to the mass over molar mass. So it's like 14 over 28, that will be equal to 0.5 moles. So yeah, the unit of moles is mol only, so you will just write mol. So this is how we will do the exam related question. Alright, so this is it for this lesson. I hope you got it. So thanks for watching this video. Thank you. Bye bye.